Spotify algorithms. How does Spotify pick the next song? By Kyren, Rachel, Jenna, Jaden, and Elias. What is the Spotify algorithm for choosing the next song played? Spotify uses multiple algorithms to find what song to play next. One of the algorithms includes stylometry analysis, which is the study of linguistics that's mainly used on written language. For our project today, we'll be analyzing and simulating how using stylometry is used to pick the next artist to play on Spotify. We gathered a total of 3 articles from Rolling Stone that were published in the past year on 4 different artists. 1 primary artist and then 3 other artists that will get compared to the primary artist. We then adapted a Python code to calculate the chi-squared of the similarity of words between the primary artist and each other artist, along with omitting repeated or structured words such as the, as, and. After calculating the chi-squared of the 3 other artists, the one with the lowest is the most similar.
Okay, and next we'll be talking about the artists that we analyzed and why. So we chose 4 artists that are predominantly considered to be in different genres, and we had SZA to be our primary artist, with her genre being predominantly in R&B, Lady Gaga with her genre being true pop, Billie Eilish, whose genre was alt pop, and Ice Spice, whose genre is rap.
For our primary artist, we chose SZA. She's an American singer and songwriter. She's known for her albums Control and SOS. Her main genres include R&B, soul, and hip-hop. Her accolades include an American Music Award, a Grammy Award, a Guild of Music Supervisors Award, and 2 awards from Billboard Women in Music. For the second artist, we chose Lady Gaga. She's an American singer, songwriter, and actress. She is known for her image, reinventions, and musical versatility. Her genre is true pop, electropop, and dance pop. Her accolades include 13 Grammy Awards, 2 Golden Globe Awards, and 18 MTV Music Video Awards.
Looking at our third artist, Billie Eilish, she's also an American singer and songwriter, and she first gained public attention in 2015 with her debut single, Ocean Eyes. Her genres include alt pop and electropop. Regarding her career, her accolades include 7 Grammy Awards, 2 American Music Awards, a Golden Globe Award, and an Academy Award. And lastly, looking at Ice Spice, she's an American rapper from New York City, and she debuted in 2021 and hit it big in 2022 with her hit song, Much. Her genre includes rap, hip-hop, and drill music. And regarding her career, she was named the breakout star by Times Magazine and is currently performing at concerts around the world. We personally believe that Ice Spice is the most similar to SZA.
Step 3, methods. Step 1, article selection. To maintain consistency across all artists and articles, we chose all of our articles from Rolling Stone. Overall, we just prioritized articles with higher links that were all published within the past year. This way, our articles can provide as much data through its words as possible, but we also want the articles to reflect the most up-to-date version of our artist for accuracy purposes. For each artist, we found 3 separate articles to provide as much information as possible. Step 2, compiling text. To compile our text, we copied and pasted the main body of each article into their own Google Doc file, and then converted each of these files into a text file. We renamed these articles to show the artist that the article pertains to, and then numbered them out of 3. After this, we uploaded all of our text files into our code. For each artist, we declared a list of their 3 articles and a list that combines all of the words across the 3 articles, and then finally create a dictionary that has the artist names as keys and the words from the articles as the values. Step 3, removing and adjusting words. Since we're only concerned with words, we made sure to remove all punctuation from each artist's word bank, and then we converted all words to lowercase so that capitalization would not matter. We also removed a list of extremely common words from all artists' word banks, such as the, and, she, I, etc., that are too common to provide any useful information. These words are also just so common that they won't really differentiate in use between artists. Similarly, we removed additional common words that we noticed were used extremely frequently across all of our artists, such as singer and music. These words wouldn't provide any useful information since every artist in our list is a singer and they all release music. However, more obscure words such as pop or tour may provide more information on what an artist is actually like. Step 4, utilizing word frequency. To ultimately calculate our chi-squared value for each artist, we must first compile a list of our top n most frequent words between our primary artist and our current secondary artist. In this case, we're finding the top 50 words, so n equals 50. This list will be represented by the most freq words variable as seen in the first line in our code. Then we need to calculate 2 different variables, count 1 and count 2, that will later be used as arguments when calling our math115 chi-squared function. For each of our count variables, we must first call our find freaks of words function as shown on the next slide. On this slide, you'll see our find freaks of words function, which takes in 2 parameters, with the first being a word list and the second being a token list. In this case, our word list will contain the top n words across both artist articles, which is our most freq words variable from our previous slide that we calculated. Our second parameter is a token list, which refers to the top n words across a single artist's articles. For count 1, our second argument when calling find freaks of words, which is referred to as a token list, is shown on the previous slide. This will be the top n words from our primary artist, SZA. For count 2, the second argument will be the token list for the current secondary artist. The math115 chi-square value takes in obs count 1 and obs count 2 as its parameters, which just stand for observe count 1 and observe count 2. These parameters representing our count 1 and count 2 variables as calculated on the previous slides. Overall, to review what we have done so far, our obs count 1 parameter, which is just our count 1 calculation, represents the amount of times each word in our word list, which is the top 50 words across both of our primary and current secondary artists, shows up in the primary artist token list. Similarly, our obs count 2 parameter, which is just our count 2 calculation, represents the amount of times each word in our word list shows up in the current secondary artist token list. The next step is to find the observed versus expected frequencies for each artist. We can do so by first setting a variable n to equal the top n words we want to analyze. As seen on previous slides, we are going to be using the top 50 words. Then we create a totals for each category variable, which represents the total amount of times the current word we are analyzing shows up within obs count 1 and obs count 2. We do this for all top 50 words. Next, we need to calculate the expected word frequency for our primary artist, which will be represented by the xfreq1 variable, which stands for expected frequency 1, and the expected word frequency for our current secondary artist, represented by the xfreq2 variable. To do so, for the current nth word, we need to divide the frequency that the current word shows up between both of our observed counts by the ultimate frequency of every word combined across both counts. Then for xfreq1, we multiply this result by the total frequency of every word in our obs count. Then for xfreq2, we multiply this result by the total frequency of every word in our obs count 2. We must do this step for the total n most frequent words, in this case, the top 50 most frequent words. This essentially produces the amount of times we expect each word to show up within each artist's articles. The image to the right shows the complete formula for calculating our chi-squared value, which is where we square the observed frequency minus the expected frequency, and then divide this by our expected frequency. We do this for each word in our top 50 words and then create a sum of these results. Our two obsmin x square over x variables represent the formula as shown in the previous slide. We utilize this formula twice, once for the expected and observed values between the top 50 words for both artists combined, and again for the expected and observed values for the top 50 words of just our secondary artist. The chi-squared value variable represents the complete sum of all of these frequencies. Completing this process for each of our secondary artists is how we ultimately get our results.
So moving on to our results, after implementing all of our methods in Colab, we got Billie Eilish with a chi-square value of 158.53, Lady Gaga with a chi-square value of 167.41, and Ice Spice got a chi-square value of 209.14. And according to the chi-square test, the artist most similar to SZA is Billie Eilish with a chi-square value of 158.53. This is because out of all three additional artists, Billie Eilish has the lowest chi-square value, making her more statistically similar to SZA. Taking a look at more visual representations, I converted the top 50 most frequent words and their frequencies between SZA and the additional artists into 3D graphs. Starting with Billie, you can see SZA in blue and Billie Eilish in green, and you can see that towards the beginning of the graph on the left-hand side, the green and the blue tend to match pretty similarly, and you can see there's only two significant windows where you can see the green peeking through. But for the most part, the blue and the green match, and there's not really much room for one color overpowering the other. But then moving on to Lady Gaga, you can see that the same peak on the left-hand side, there's a lot more green in that area, and just generally, the peaks are higher for green compared to the blue, and this means that Lady Gaga is slightly less similar to SZA in comparison to Billie Eilish, because Lady Gaga has more unique frequencies of words. Then lastly, we have SZA versus Ice Spice, where the initial spike of green is much taller and thicker compared to the other two graphs. Additionally, you can see that the blue and green hardly ever match, and all three of these graphs show that Billie Eilish is the most statistically similar to SZA compared to Lady Gaga and Ice Spice.
In the next section, I will be interpreting our data. As previously mentioned, our artist match was Ice Spice and SZA. We believe that the two artists would be the most similar due to their mainstream popularity and the fact that they have been in the headlines and playlists recently. However, our data proves that the artist most similar to SZA is deemed Billie Eilish due to the low chi-square value. A low chi-square value means that the difference between the number of one artist's frequented words and the number of another artist's most frequented words is small. On the other hand, a high chi-squared value means that there is a higher difference between the article's language used when discussing the two artists. Therefore, SZA is less similar to Lady Gaga and Ice Spice because of the chi-squared value is higher than Billie Eilish's. While our data points to the fact that SZA and Billie Eilish are the most similar artists, there are a variety of other reasons for similarity that can be explored. For example, listeners, social media presence, popularity, genre, and tours. The analysis of language itself can be skewed due to the way that Rolling Stone writes about their artists. For example, by using articles to analyze the similarities and difference between artists, it can capture the bias, the racism, and any other personally held feelings that the writer has about the artist, and it might not actually reflect the similarities between the artists that we are exploring. This goes to show that while our data shows that SZA and Billie Eilish are the most similar artists due to the language that they refer to, there are a lot of other ways that artist similarity can be proven, simply just based off of looking at different aggregations of data. For example, if we looked at the monthly listeners of artists instead of the articles about artists, we can see that in this graph, which is from April 2022 to April 2023, Billie Eilish and Lady Gaga trend in the same manner, where they both have a pretty steady popularity. On the other hand, Ice Spice and SZA both jump in popularity in 2023 due to the respective release of Ice Spice's EP on January 20th, 2023, and SZA's album, SOS, on December 9th in 2022. This leads us to believe that during this time period, Ice Spice and SZA are the most similar due to their rise in popularity. Many Spotify listeners tend to hop on the next trend. Therefore, it is easy to believe that these artists would play one after the other because they are popular.
And now we'll move on to our conclusion. In conclusion, we utilize the chi-squared formula as a means for stylometry analysis, which is one method that Spotify applies in order to decide what song to play next. For our project, we evaluated 4 unique artists: SZA, Lady Gaga, Billie Eilish, and Ice Spice. With SZA being our primary artist, we used the chi-squared formula to assess how similar Rolling Stone articles on each of the other 3 artists were to Rolling Stone's articles on SZA. And while our initial hypothesis was that Ice Spice would be the most similar to SZA than the other 2 artists, our results suggested that Billie Eilish was actually the most similar, with a chi-squared value of 158.53 compared to Lady Gaga's 167.41 and Ice Spice's 209.14. It should be noted as we conclude, though, that Billie Eilish, while she is considered the most similar statistically, it is not necessarily applicable to the Spotify algorithm in real life. And that is it. Thank you so much for your time.